We have what? Pn. Polynomial of degree n. Okay. Where sekejap ya. A apa tu? A n x to the n plus a1x plus a naught. All the a I are real. N in Z. Okay, and not it's not is more than 0. Okay, example of P1, degree 1.
Excuse me, doctor. Sorry to interrupt.
Yes.
Doctor, the thing that I don't understand over here is the n can be equal to 0. Not should be like n must be more than 0, right? It should be 1
Yes.
or 2.
And it can be equal to 0. For example, P0. P0 is A0, only reals, the A0.
Oh, okay.
Okay, for example, P0, polynomial of P0 is 7, for example.
Okay.
This is P0. Okay. Example P1. P1 is A1x plus A0. So example of P1 is Px equal to 3x plus 3 or Px equal to 4x. So this is example of P1, degree 1. Okay. P2, A2x squared plus A1x plus A0. So example, 3x squared plus 4x plus 4, for example. Or 3x squared plus 3x. Or for example, 4x squared. Okay? Any question here? So this is example of P2, P1, P0. Now the question is Pn in general. So at least An not equal to 0. At least An not equal to 0 in order to be in Pn. The rest can be 0. For P1, at least A1 cannot be 0. Otherwise, it cannot be polynomial of degree 1. P2, at least A2 cannot be 0. The rest can be 0. Otherwise, it cannot be a polynomial of degree 2. Okay. Is that okay? Surya?
Yes, doctor. Yeah.
Okay. Right. So now, let's prove Pn is a vector space. Prove Pn is a vector space. Okay. So first one, non-empty. What can you say about the empty, non-empty? Let's put together back. Pn is in the form of Px a n x to the n plus blah 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 plus a naught. Non-empty. What can you say about non-empty? Remember, told you the non-empty one is, remember about the identity. What is the identity in Pn? The identity should be like what? Px equal to 0x to the n plus blah 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 plus 0. That is 0. So at least 0 in Pn. Okay? Any question here?
No.
So this show it is non-empty. Okay, number 2, we need to show that Pn satisfies the 10 axioms. Okay, what are the 10 axioms? Okay, remember for this one, we need to say that for P1x, at least ada berapa? P2x ada 3 kan? P2x, not P1 here, okay? Salah, nanti kan you ingat degree 1, degree 2. Ambil PQR lah. For PX, QX, PQRX in Pn, okay, and CD in R, okay, you must have that because it involves the scalar multiplication. So the first one, we need to show Px plus Qx mesti ahli Pn. Okay, so Px in what form? Px in a n x to the n plus a n minus 1 x to the n minus 1 plus blah 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 plus a naught. Qx bn(x) to the n plus bn minus 1 x to the n minus 1 plus blah 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 plus b naught. Okay, what is px plus qx here? What is it? Let's try. Lydia? Apa dia px plus qx?
A plus B bracket,
Ha? Tak dengar.
A plus B bracket,
A apa?
A plus B open bracket and X N.
A plus b, an, right? An
plus
plus bn.
N,
X to the n.
N to the power of N.
Yep, good. And the rest, blah, 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 plus, what is the last?
A plus B, A naught plus B naught.
A naught plus b naught. Okay, the question is this in Rn? Rn, Pn? Yes or no?
Yes.
Okay. Since Px is in An not 0. Qx in Pn, Bn is not 0. So, we claim that this is in Pn since what? An is not 0, Bn is not 0, hence what? An plus Bn cannot be 0 also. So at least this is not 0 and we have x to the n, then P plus Q is in An. Okay? I put it here. I go to the next page, okay? So since An, Bn is not 0, then An plus Bn is not equal to 0. Hence, at least we have P of x equal to An plus Bnx to the n. We don't care about the rest of the coefficient. Dia kosong pun tak apa. Ini sudah dikira sebagai what? Polynomial of degree n. So yes, exam 1's code. Okay. Girls and boys, are you guys okay?
Okay, Doktor.
Alright. And then number 2, kita nak tunjuk is Px plus Qx equal to Qx plus Px. Okay, yes or no? Yes or no? So what is Px plus Qx? We have just now, right? An plus b n x to the n and blah 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 plus a naught plus b naught. Since an reals, bn reals, and all the coefficients are reals, real is commutative, so we can have bn plus an here. Right. So we can have bn x to the n plus b naught plus an x to the n plus a naught. So this is what? This is qx plus this is px. So axioms 2 hold. Okay? Alright, do you think you can show the rest? Or maybe the harder part is what? Number 3 is associative. Yang tu you all tunjuk sendiri Boleh Surya?
Yes, Doctor.
Okay. Saya nak tengok yang susah sikit. Number 4. 0. 0 vector. Is there a vector 0 such that? Number 4 Is there 0 polynomial such that? Alright. Or maybe you can say, is there? We don't know a 0 polynomial yet. oops, sorry. Is there Rx polynomial of degree n such that Px plus Rx equal to Px, and it is equal to Rx equal to plus Px. Is there Rx such that this hold? This show that if it is, this show that Rx is the identity in addition for the polynomial of degree n. So let's do it. So we have what? So let's Px that we have just now. An x to the n plus blah 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 plus a naught Rx equal to Bn x to the n plus B naught. Okay, so what is Px plus Rx? It is An plus Bn x to the n plus A naught plus B naught plus then this is must equal to An x to the n plus A naught must equal to Px. So can you find what Rx is? So for the polynomial it's easy, we just what? Equate the coefficient. Because these two are the same, we just equate the coefficient with the same degree. So this show that what? An plus Bn equal to An, and hence Bn equal to Atika 0. That's right. And we have blah 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 A naught plus B naught equal to A naught, hence B naught equal to 0. So Rx must be the form of 0x to the n plus 0x to the n minus 1 plus blah 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 plus 0, that is equal to 0. Okay. How about the inverse? Can you guys do the inverse? Is there any vector or is there any maybe Rx such that Px plus Rx equal to 0 vector, 0 polynomial? And find what is Rx. One, let's say, Aisha here, right? Can you please do it and post up in WhatsApp group? Is Aisha here?
Yes, doctor. Number 5.
Okay. Is there, number 5, exam number 5, is there Rx polynomial of degree n such that Px plus Rx equal to 0, the identity, or we can put like this, 0x equal to Rx plus Px. And then find what is Rx. Okay, back a little while, remember this one, you need to prove this side also. This one is, now we got Rx is 0 plus Px give you Px. Okay, tertinggal satu kan. So next is 0 is 0x plus px equal to px? The answer is yes. We're done. Okay. Need to show two parts. This part and this part. Okay. So Aisha, you do this. Snap. Put in the WhatsApp group.
Okay, Doktor.
Okay, Aisha.
Doktor, I only get half.
Okay, show it. Show. Don't worry. Show it. Okay, let's see. Where's the WhatsApp? Mana WhatsApp saya? Dekat Safari. Okay. Okay, let's see what Aisha has here. Okay. Okay, a n x to the n plus blah 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 and not, and that is equal to 0. It should give us, what is this? Okay, we don't want commutative, right? We want, this one doesn't give you anywhere. This is just show commutative. We want, is there any this one give us the px plus the rx equal to 0 and the other way around. Oh, okay, sorry. You just write what I have just now. So we want to find what is Rx, such that this equation holds. So can you find it? So we have what? Next we have an plus bn x to the n plus whatever it is there, a naught plus b naught. This is equal to 0 polynomial. 0 polynomial looks like what? 0 x to the n plus blah 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 plus 0. Now can you solve for the b? So again, we need to equate the coefficient. So an plus n equal to 0. So what is bn?
Negative
Aisyah?
an.
Negative an. Blah, 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 blah. We have a naught plus b naught equal to 0. What is b naught? Negative a naught.
A naught.
Yes. So our Rx looks like this. Negative a n x to the n plus blah, 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 negative a naught. So is this, the next question we need to ask, is this in Pn? What is your reason? Is Rx in Pn that we got just now? Remember, in order to be Px in Rn, at least An cannot be 0. At least. If it has until A not, N not 0. But at least An not 0. If An not 0, what happened to negative An?
0.
Negative An cannot be 0 also. So at least negative An not be 0, then Rx is in Pn. Because it has coefficient of degree n. So the answer, since An is not 0. So yes, Rx in Pn. So the identity for the Px, that is Rx, looks like this. Or we can say, yes, the identity of Px exists. That is Rx. Okay? Alright?
Okay, doctor.
Alright. Done. Okay, already what? We already video that. So it's okay. Okay. Alright, so we have shown this. So Rx in the form of a negative An x to the n plus blah 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 negative. Okay. I will discuss 6 and the rest you do it. Scalar multiplication is Cpx in polynomial of degree n, C in R. real number. This is easy, right? Is we have px equal to an x to the n plus blah 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 plus a naught. So cpx equal to can x to the n plus ca naught. So the question is this is cpx in Pn? What is your answer? Anis Nadira, what is your answer? Okay, Anis, what is your answer? Is cpx in Pn? cpx is in this form. At least you must show that can not equal to 0. Anis, is can not equal to 0?
No.
So can not equal to 0. Why?
I don't know.
Why? Because in order px to be in an not equal to 0, right? So the the scalar multiplication c not equal to 0 also. So what is can here?
Not equal to
Can
0.
not equal to 0. So yes, cpx is in
N.
polynomial of degree n. Okay?
Yes.
Alright, so you do the rest. It's just similar. Okay, but the argument need to be there. Okay, need to be clear. Why is it? Why is it? Right? Okay. Let's continue. It's almost 9. It's just very quick. Okay, now let's see examples of non-vector space. I claim that integer, the set of integer that is z, is not a vector space. Why is it? If it is not a vector space, what you need to do, you don't have to prove everything, all the 10 axioms. If the question is like this, show that the z, the set of integers, is not a vector space. What you need to do, just find which axiom does this z fails. Can anybody give me what axiom does this z fail? Anybody? Give example. To disprove, remember we can give examples. We need to give examples, in fact. Siapa nak cuba? I'm Iman. Is Muhammad Iman here? Iman? Iman ada tak tadi?
Ada, doktor.
Iman ada suara tak?
Iman tak ada.
Iman tak ada eh? Oh, Iman tak ada. Amiruddin lah. Amiruddin? Ini saya punya nota tak. Amiruddin? Yang mana dia fail, Amiruddin? Ingat ni set of integer. Kita tambah. Dia non-empty, 0 is inside, right? Kita tambah, apa tu? Dia commutative sebab integer commutative. Dia close Sebab integer, 2 tambah kita tambah 2 integer jadi integer. Integer whole commutative associative. Integer ada zero vector tak? Zero. Integer ada inverse tak? Ada, the inverse of the numbers. Masih dalam integer. Agak-agaknya yang mana dia tak menepati? Which axiom it doesn't hold? Nurudin? Nurudin ada tak?
Dr. Merudin absent.
Oh, Nurudin absent eh? Apalah ni? Saya panggil semua absent ni. Sekejap. Arif ada? Saya nak kena tengok baliklah kedatangan ni. Tadi.
Dr. Amiruddin ada. Mic dia tak function.
Oh, mic dia tak function. Dia tulis tak dalam WhatsApp group? Dalam WhatsApp group pula. Tulis Amiruddin, tulis dalam WhatsApp group ataupun dekat chatting. Chatting Webex. Mana saya punya Webex? Webex saya dah hilang ke? Chatting Webex. Tulis Amiruddin cepat. Mana senang lah. Dalam WhatsApp group ke, dalam chatting Webex ke? Okay. Cepat. Kat pukul 11 dah. Kat pukul 10 dah.
Doktor, untuk chapter ni masuk final ke?
Masuk. Saya akan beritahu nanti. Amiruddin. Dah. Teka. Yang mana dia tak? Encik Azim masih menulis. Cakap je kalau tak nak tulis, cakap je yang mana dia tak hold dan bagi example. Janganlah tulis lama-lama. Okay, I'll give you a hint. Amiruddin, it doesn't hold axiom number 6. Scalar multiplication. Ingat, the scalar must be real. It doesn't hold the scalar multiplication. Give example. Amiruddin. I'm trying to think of an example. Amiruddin, janganlah lama-lama. Kat pukul 10 dah ni. Doesn't hold the scalar multiplication. It means you take a scalar, we times with an integer, it is not an integer. Ingat, C can be any reals. Ada siapa tak nak tolong Amirudin? Amirudin tu fikir pun lama sangat nak pula tu. Who wants to help Amirudin? Siapa nak tolong Amirudin?
Doctor,
Ya,
let me try.
okay. Cepat, apa dia?
If it is not closed under scalar multiplication, but z is a set of integer, so it should be like tak pasti ya.
Take any example. Take any integer.
Any integer.
Apa-apa
Okay.
integer, apa nombor?
Okay, 2. Say.
Okay, 2. And then take any C in real numbers that make it is not, when we times that C with these 2 is not an integer.
Z.
Huh?
Oh, it's not an integer.
Yeah,
So it's not an integer.
apa dia? Apa-apalah kan, I take 3 and I take C is equal to half. And when I times C with 3, the half with 3, I get 3 over 2. And 3 over 2 is not an integer. So this example show that Z is not closed under scalar multiplication. So Z cannot be a vector space. Okay? Amirudin?
Doctor, if
Yeah.
if z we take one integer, one real number, any real number, like 3, let's say, and then c we take like 4 in let's say, and then when we times we get 12. So it is under scalar multiplication, right?
No, now remember, in order Z to be closed in scalar multiplication, it should be true for all, not just for some.
Oh, okay.
Okay, now we have checked at least one that doesn't hold, then this Z is not a, cannot be a vector space. Okay? Okay, let's do number 2, and I want you try to do the rest of the examples. I have what? How many examples there? I have 3, 4, 5. Okay? Okay, let's see this set. Set S is ordered pair XY where the X bigger or equal to 0 and the Y bigger or equal to 0. Okay? Example that B set S can be is what? 0, 0 is inside, right? 0, 1 is inside and the rest. 1, 0 is inside and the rest. So these are example of set S. Okay? I claim that this set S is not a vector space. Which one? Which axiom it doesn't hold? Okay, again for this example, it doesn't hold the scalar multiplication. In other words, it is not closed under scalar multiplication. In other words, S doesn't hold the axiom number 6. You cannot just say like this, you need to give examples. So let's take 1, 1 in S, and I take negative 2, the C. C can be anything, okay? C can be reals. Look back the axiom. C is reals. Okay? And when I multiply this, I get negative 2, 2. So is negative 2, 2 in S? The answer is no. We don't have any, what? Negative number in S. Right? So we say that S is not closed under scalar multiplication. Okay? So times is up. Allah Akbar, cepatnya masa berjalan. Sekejap je. Okay? So try do exercise number 3, 4 and 5 to show that those sets are not a vector space. Boleh? Boleh cuba? Try, eh? So in meantime, you can just put in WhatsApp group your question or your working for those exercises before our next class on Monday. So we cannot just like prolong these exercises because we need to go further because we have many more, okay, material to cover for the finals. Okay? The final will cover chapter what? If we look at the pro forma, the final will cover chapter pro forma pula apa tu? Planning tu kan? Okay, planning that you have. Final will cover chapter,
3, 4, 5.
yep, 3, 4 and 5. That's right. Thank you.